Any questions? And tests are almost graded. Not enough to hand them back right now, but some people are doing well, some people are not. Some people are in the middle. I know, it's a shock. But that hopefully narrows it down for you. I believe that was, I usually derive it as opposed to just trying to regurgitate it from memory. Is that right? That's what we left off with. Got a nod right there. All right. Let's manipulate it a little bit. It's a little bit of a spoiler I've already done before. Speed squared. This is the escape speed. 2 big G mass of whatever that central body is over the radius of that central body. So how fast an object needs to be going from the surface, assuming that there's no interference along the way. So in my scenario, I launched it from the surface of planet X, but I did, it doesn't hit any, there's no air resistance. It doesn't hit a planet, it doesn't hit a flying cow, etc. If we just flop across that diagonal, we get r sub x is equal to 2g mx over v squared. So if I know the escape speed, I can figure out what the radius of the planet is, assuming I know the mass. And if there is a maximum speed, which there's a lot of evidence to support, then the radius of a black hole, in other words, the radius that a certain mass would need to be so that nothing can escape, is done by the formula 2g mass of whatever that central body is over the speed of light squared.
Is the C like a pretty standard thing for light speed?
Yes, yeah. Although some textbooks will use C for the speed of sound as well, but those people are just crazy. Now there is a specific value for it. Matter of fact, the meter is defined by what the speed of light is. However, for what we're doing right now, 300 million meters per second. $186,000 miles per hour. That one's off. All right. So let's take our Earth. If our Earth could somehow, without losing any mass, get crushed down into a small object, how small would it need to be in order to become a black hole? This radius right here is known as the Schwarzschild radius. Except usually supposed to be pronounced with a better German accent. Schwarzschild was a physicist, one of the many losses of World War I. Died from the effects of a mustard gas attack. But while he was trying to recover in the hospital, he wrote 2 rather important papers. And one of which he was honored by it with this, but basically he derived this radius of a black hole. Now, he used more sophisticated math, but you still come up with the exact same answer. So sometimes special relativity, which actually is using general relativity, but relativity sometimes is referred to as semi-classical because there are some roots still in it. So this would be 2 times 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared times mass of the Earth, 5.9 feet, times 10 to the 24th kilograms, divided by the speed of light, 3 times 10 to the 8th squared. If someone would be kind enough to work that out.
So that's newtons meter squared over kilogram squared?
Yes. anyone working this out at the moment?
What's the subscripts for the R that says Schwarzschild?
Oh, BH for black hole. And the answer is you have an answer, Tristan?
It's, yeah, 0.008636.
0.008633.
88.
Okay, that seems familiar. Anyone else get the same thing?
Yeah.
Alright, what
Wrote it
units?
wrong, though.
What's that?
You wrote it wrong though. I
Oh.
think. From what I got at least was 0.008886.
Oh, I got the 8 and 6 flipped.
8863.
8863. Ah, sorry, misunderstood. Alright, units?
Meters,
Yeah. How'd you get that?
because it's the radius.
Yes. I mean, you could go through and do the unit cancellation, but ultimately, you end up with meters. All right, so that's about 9, just shy of 9 millimeters. So if the Earth shrank down to, so that's the radius, the diameter would be, I guess, somewhere around there. So if the Earth shrank down to that size right there, it would become a black hole. But what about our sun? Planets, to our knowledge, have not become black holes. Stars have. Is our star going to become a black hole eventually? Well, based on current theory, no. When you're dealing with stars, you got two things going on. Two major things going on. You get hydrogens, well, actually more specifically protons, and a proton get slammed together and they become a helium. The helium has less mass than the two protons, and so there's a loss of mass. Where does the mass go? Into energy. The expression E equals mc squared, or E sub rest energy is the rest mass times, that's a C squared. There is a mass energy conversion. And so we have this energy that's working its way out. And at the same time, there's this gravitational pull, because all these things have mass, trying to pull it in. And it's this balance between the two, that if it's balanced, that the star stays basically the same size, like ours does. But as the energy is being released, it's losing mass. So the gravitational pull becomes less. And the amount of energy being produced also becomes less, because I can slam two heliums together and create a beryllium, but not as much energy comes off of that as two hydrogens. That's why there's a hydrogen bomb and not a helium bomb. So So we got these two warring factions. Now, eventually, there's all the hydrogens, the protons, will have been used up, and then they start going into whatever the next elements are, and it'll keep working its way until it gets to iron. I think iron is that anything below iron, I can slam together with another thing below iron and have energy come out of it. Anything above iron, the only way to get energy out of it is to split it. Thus, the atomic bomb uses uranium, which is down at the bottom. So which runs out first? The mass or the energy being used? Well, it depends upon the star. Our star is going to run out of mass before it runs out of the energy, in a sense. And so our star should, based upon current theory, should just get bigger and bigger. There are some who say, so not to scale, that the sun will keep expanding and eventually the Earth will be engulfed by the sun. Well, really, if the sun starts expanding, that means it's lost some of its gravitational pull. And so eventually the sun will be here where we are right now, but the Earth, because the sun has less gravitational pull, will move farther out. And so the sun will be here, but the Earth won't be. And humans would be gone, long gone by then anyway, according to current speculation. If the radiation pressure is not enough for the amount of mass that you have, so if you got the really huge stars, it will collapse in on itself. If it collapses in on itself, in one scenario, it'll collapse in on itself so quickly that enough heat's generated that the thing will then explode and you get novas and supernovas. Or if the gravitational pull is enough, it'll collapse in on itself and it won't explode because there's so much gravitational pull, and you get the black holes. That's where the theory is right now. Questions? All right. Now for something completely different.
Actually, I did have one question I
Oh,
just thought.
yes.
So can planets not become black holes? Or I guess it needs the hydrogen and the protons to send out the energy.
Yeah, we're not producing energy like that.
Yeah.
I guess we have radon gas, which keeps the caves warm. But yeah, we're sticking together because we have a crust that's keeping us together there. So yeah, I've never heard of any theory where a planet becomes a black hole. It would have to be a gas supergiant or something like that. I don't know if they exist or not. Yeah, I was trying to think of whether Jupiter could, but Jupiter's not all gas and plasma. It's got a liquid core. At least the last time I was there.
Last Tuesday.
Yeah, it was still liquid at that point. Now, if we set the clock ahead an hour and I'll sneak out, would Abraham wake up and wonder what happened? Other questions before I continue erasing?
What if I actually had a heart attack? I was like, now.
Like a Twilight Zone episode. All right, we're going to shift gears. That's the end of 7. Let's talk about chapter 8. We'll start a new video.